As we saw in the previous video, molarity can be, there's three different components to that molarity equation. Okay, molarity, as we saw, is molarity is equal to moles over liters. And many times, yes, you'll be asked to find the molarity, but many times you might be asked to find the moles, or you might be asked to find the volume in liters or milliliters as well. So let's make sure that we know how to solve all of those different types of problems. So if we're trying to find molarity, we've already seen that equation. It's moles over liters, okay? And then we did one example, it's right here actually, for if they're asking us to find the moles, we know that moles are equal to the molarity times the liters, okay? And then the third thing they might ask you to do is they might ask you to find the volume. And anytime they ask you to find the volume of something that's in the denominator of a fraction, you simply switch that denominator with the whatever is over here. So those two can just switch. So the way that that equation is going to look is that to find the volume in liters, that equals moles over the molarity. So no matter what they're asking you for, you've now got, this is the equation to find molarity, here's how you find moles, and here is how you find the volume. So example A says find the molarity if it contains 0.184 moles of sodium carbonate in 0.250 liters of solution. So it's already in moles and the volume's already in liters. So we're just going to take 0.184 moles and we're going to divide by 0.250 liters. So 0.184 divided by 0.250. And again, hopefully you're checking your answers here with me. You should get an answer of 0.736. Again, you can either put big M or put moles over liters. Okay, letter B, calculate the molarity of a solution that is created by mixing 34.5 grams of potassium acetate and 145 milliliters of solution. So in this one, they're giving us grams. So like we saw in the previous video, the first thing that we need to do is we need to convert our grams to moles. So the molar mass of potassium acetate is going to be potassium 39.1 plus 2 carbons is 24, 3 hydrogens is 3, plus 2 oxygens is 32, and that is going to equal 98.1 grams in 1 mole of potassium acetate. 34.5 divided by 98.1 equals 0.352 moles. And now again we're trying to find the molarity, which again we saw up here is moles over liters. So they give us the volume in milliliters, so I'm just going to move that decimal point 3 spaces to the left real quickly to convert that to liters. And I'm going to take my answer, which I had on my calculator screen already, and I'm just going to hit the divide button and divide by 0.145, which gives me a concentration of 2.43 molar is how you would say that. Okay, letter C says calculate the mass of lithium hydroxide needed to create this solution right here. So they're asking us for the mass. So we kind of come back up here and think, okay, which of those ones should we find? Should we find the molarity? Should we find the moles? Or should we find the volume? In this case, hopefully you recognize, oh, when I have the moles of something, I can use the molar mass and convert to grams. So I'm going to get moles. And so moles is equal to the molarity times the volume in liters. So that's what I'm going to do. I'm going to take the molarity, which is 1.25. And remember, big M is really just moles over liters. And the reason I write that is because it helps me remember, oh, it can't be 650 milliliters. It's going to be 0.650 liters. And that way, liters will cancel. You've got liters on the top and liters on the bottom. So now we're just going to take 1.25. We're going to multiply by 0.650, and we get an answer of 0.813 moles of LiOH. And then we need to get the mass of that. So the mass of lithium hydroxide, lithium is 6.9 plus 16 for oxygen plus 1 for hydrogen. There's 23.9 grams in 1 mole. Notice I put moles on the bottom so they'll cancel. multiply that by 0.813, and I get a final answer of 19.4 grams of LiOH, which means that if I take those 19.4 grams of LiOH and I put them into a beaker, and then I start adding water until I get to about 650 milliliters, guess what? I'm going to make a 1.25 molar solution of lithium hydroxide. That's what that number is telling me. It's telling me, okay, that's how much lithium hydroxide I need to make this solution a 1.25 molar solution. Okay, and now our last one is what volume of a 0.189 molar solution contains 12.5 grams of sodium sulfate? So in this one, they're asking us for the volume. So let's come back up here again real quick and look. Volume, which is in liters, is moles over molarity. So I need to get the moles first of all. They gave me the grams. So I'm going to take 12.5 grams of Na2SO4, and I've got to convert that to moles. So sodium's 23. There's two of them. That's 46. Plus sulfur is 32.1. Plus the 64 from the 4 oxygens is 142.1 grams per mole. So now I'm just going to take 12.5 and divide by that answer, and I get 0.088 moles of Na2SO4. Okay, and remember, it's moles on top, molarity on the bottom. Okay, so the molarity here is 0.189. So moles on top, molarity on the bottom. And remember again, molarity is moles over liters. We saw this with the gas laws with PV equals nRT, that when you put R on the bottom, remember it was liters, atmospheres, and then we put Kelvin mole on the top. Kind of the same thing here. If you're going to write it, you're going to put moles right here, and liters actually goes on the top. So moles will cancel, and notice all we have left is liters. So it's 0.088 divided by 0.189, and we're going to get a final volume. The volume is equal to 0.466 liters. And then if they didn't, they just said what volume. But let's say they said what's that volume in milliliters, then we would have to move that decimal point over 3 spaces to the right, which would just be 466 milliliters. Okay, so in all of these problems, the first couple we were just getting the molarity, moles over liters. In the second one, or in the third one here, letter C, to get the mass or the moles, we have to multiply. Notice that we multiplied the molarity times the volume. And then in our final one here, when you're trying to find the volume, remember volume is equal to moles over the molarity. Moles on top, molarity on the bottom. Okay, and so that's what we did in this last one. And those are the 3 different ways that you're going to use that molarity equation.